The issue at hand involves a parallel path for return current, which arises from incorrectly bonding the equipment grounding conductor, abbreviated EGC, and the grounded conductor, or neutral, at both the transformer and the service disconnect. According to the National Electrical Code, NEC Section 250.24, b. The equipment grounding conductor and the neutral conductor must not be connected at any point in the system beyond the service entrance. Furthermore, NEC Section 250.53, b. mandates that the equipment grounding conductor for a service must be installed alongside the supply side phase conductors within an enclosure, raceway, or cable tray. In addition, NEC Section 250.53, b specifies that the neutral conductor cannot be used as an equipment grounding conductor when the equipment grounding conductor and the neutral are improperly bonded as described. Current can flow back to the source through two distinct paths. Firstly, there's the normal path through the equipment grounding conductor. Secondly, there's a parallel path through the neutral conductor which is connected to ground at the transformer. This situation creates a parallel path for the return current, potentially leading to several adverse consequences. These include firstly, increased current flow in the neutral conductor, which can lead to overheating. Secondly, false tripping of circuit breakers or fuses due to the current imbalance. And thirdly, interference with sensitive electronic equipment because of the circulating ground currents. The statement that this setup had to be done this way contradicts established code requirements and safe electrical practices. The correct solution involves separating the equipment grounding conductor and the neutral conductor at both the transformer and the service disconnect. The equipment grounding conductor must be run with the phase conductors, adhering to NEC Section 250.53. b. It is essential to ensure that the neutral conductor is not used as an equipment grounding conductor. Additional factors to consider include ensuring that the size of both the equipment grounding conductor and the neutral conductor is adequate for the intended load. All connections for both the equipment grounding conductor and the neutral conductor must be tight and secure to minimize resistance. It is highly recommended that the entire electrical system be thoroughly inspected and tested to ensure full compliance with all applicable code requirements and safety standards. This inspection should verify that all grounding and bonding connections are properly made and that the system is free from any other potential hazards. Remember, proper grounding and bonding are critical for electrical safety and equipment protection. Failure to adhere to these standards can result in dangerous conditions and costly damage. It is always best to consult with a qualified electrical professional to ensure that all work is performed in accordance with the NEC and local regulations. In the context of a 600 amp service, meticulous attention to detail in grounding and bonding is paramount. The large current capacity means that any faults or improper connections can quickly escalate into significant problems. The equipment grounding conductor's role is to provide a low impedance path for fault current to return to the source, facilitating the quick operation of overcurrent protection devices like circuit breakers or fuses. This rapid response is crucial in preventing electrical shock hazards and minimizing damage to equipment. The neutral conductor, on the other hand, carries the unbalanced current from the load back to the source under normal operating conditions. When the neutral and equipment grounding conductor are improperly bonded, a portion of the neutral current can flow through the equipment grounding conductor and any metallic parts connected to it, creating the potential for electrical shock. Furthermore, this parallel current path can lead to inaccurate readings on sensitive electronic equipment and can cause electromagnetic interference. The presence of harmonic currents, which are common in modern electrical systems due to the proliferation of electronic devices, can exacerbate these problems. Harmonic currents can cause increased heating in conductors and transformers, leading to premature failure of equipment. Properly separating the equipment grounding conductor and neutral conductor and ensuring that all grounding connections are tight and secure are essential steps in mitigating these risks. When installing a watt-hour meter on a 600 amp service, it's crucial to verify that the meter is properly grounded and bonded. The meter enclosure should be connected to the equipment grounding conductor to provide a safe path for fault current. The meter should also be installed in accordance with the manufacturer's instructions and all applicable codes and standards. In addition to the NEC requirements, it's important to be aware of any local amendments or regulations that may apply. Local jurisdictions often have their own specific requirements for electrical installations, and it's the responsibility of the electrician to ensure that all work is performed in compliance with these requirements. When encountering a situation where the utility company or line department insists on an improper grounding or bonding configuration, it's important to respectfully but firmly explain the code requirements and the potential safety hazards associated with the proposed method. It may be necessary to escalate the issue to a higher level within the utility company or to involve a third-party electrical inspector to resolve the dispute. Ultimately, the safety of the electrical installation and the protection of people and property should be the overriding concern. Remember, electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable performing a particular task, or if you're unsure about any aspect of the electrical code, it's best to consult with a qualified electrical professional. A properly installed and maintained electrical system is essential for the safe and reliable operation of any building or facility. In summary, the key points to remember regarding grounding and bonding on a 600 amp service are: firstly, the equipment grounding conductor and neutral conductor should only be bonded at the service entrance. Secondly, the equipment grounding conductor must be run with phase conductors. Thirdly, the neutral conductor should not be used as an equipment grounding conductor. Fourthly, all grounding and bonding connections must be tight and secure. Fifthly, the entire electrical system should be inspected and tested to ensure compliance with the NEC and local regulations. By following these guidelines, you can help to ensure the safety and reliability of your electrical system. Furthermore, it is important to use appropriately sized conductors for both the equipment grounding conductor and the neutral. The size of the equipment grounding conductor is typically determined by the size of the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. The size of the neutral conductor is determined by the calculated neutral load, which is based on the unbalanced current in the circuit. In some cases, the neutral conductor may be required to be larger than the phase conductors, particularly in systems with a high percentage of nonlinear loads that generate harmonic currents. When working with large conductors, such as those used in a 600 amp service, it's important to use proper tools and techniques to ensure that the connections are made correctly. Torque wrenches should be used to tighten connections to the manufacturer's specified torque values. Anti-oxidation compounds should be used on aluminum conductors to prevent corrosion and ensure good electrical connection. The use of proper labeling and documentation is also essential for maintaining a safe and reliable electrical system. All panels, circuits, and equipment should be clearly labeled to identify their function and voltage. Accurate as-built drawings should be maintained to document the location of all electrical components and wiring. Regular maintenance and inspection of the electrical system are also crucial for identifying and addressing potential problems before they become serious. This includes visually inspecting conductors and connections for signs of damage or corrosion, testing the operation of overcurrent protection devices, and measuring voltage and current levels to ensure that the system is operating within its design parameters. Any deficiencies or problems that are identified during maintenance and inspection should be promptly corrected by a qualified electrical professional. It's also important to be aware of the potential hazards associated with working on electrical equipment, particularly on a high current service like a 600 amp system. Always de-energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. And follow all applicable safety procedures and guidelines. If you're not sure how to safely perform a particular task, don't attempt it. Seek assistance from a qualified electrical professional. Grounding electrode conductors play a critical role in providing a lower impedance path for fault current to return to the source. These conductors connect the equipment grounding system to the earth, providing a reference point for voltage and helping to stabilize the electrical system. The NEC specifies the types of grounding electrodes that are permitted, as well as the methods for installing them. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. In addition to the equipment grounding conductor and the grounding electrode conductor, bonding jumpers are also an important part of the grounding and bonding system. Bonding jumpers are used to connect metallic parts of the electrical system together, such as metal conduits, enclosures, and equipment frames. This ensures that all metallic parts are at the same electrical potential, minimizing the risk of electrical shock. The NEC specifies the size and installation requirements for bonding jumpers. It's important to note that the requirements for grounding and bonding can vary depending on the specific application and the type of electrical system. For example, the requirements for grounding and bonding in a healthcare facility are different from those in a commercial building. It's important to consult the NEC and other applicable codes and standards to ensure that the grounding and bonding system is properly designed and installed for the specific application. When upgrading or modifying an existing electrical system, it's important to ensure that the grounding and bonding system is also upgraded to meet current code requirements. This may involve replacing undersized conductors, adding additional grounding electrodes, or improving the bonding of metallic parts. Failure to upgrade the grounding and bonding system can compromise the safety and reliability of the electrical system. The proper design, installation, and maintenance of the grounding and bonding system are essential for ensuring the safety and reliability of any electrical system. By following the NEC and other applicable codes and standards, you can help to protect people and property from the hazards of electricity.